Good afternoon, everyone. All right, let's talk robots interacting with humans. So I've actually been rewatching Lost in Space on Netflix. Clara, I know you actually haven't seen the show, so this reference might fall a little flat, but you have. And so essentially, it's this robot that befriends a child, at least in season 1. I haven't seen season 2 yet. But there's like emotions involved, and they're getting along, and they're protecting each other. How close are we to that sort of world? Maybe let's start with you, Mike, since you've actually seen what I'm talking about.
As close as we are to Alpha Centauri, we're really far away. I think there's elements of there's discrete elements that we can do, but that whole picture of what that robot's doing and the physical part, way, way beyond our means. The emotional part, I think you are seeing more there. There's more, because you can do that through gesture and interaction, and there's some interesting startups doing things in that space. But I think, and that's why people are going for more the emotional side so far rather than the functional side.
Yeah, I mean, both of my children were good friends with robots when they were little. My son and his Roomba like to play together a lot, and they're toddlers. My daughter had a agricultural robot that she asked me when I left that company if when that robot got too old to work, could we please keep him? And we did, and he lived in my kitchen for a year or so. But I think that is, for fun, as you're saying, that the level of understanding and ability and consciousness, I guess, that sounds like what you're describing. We're a long way from anything like that in the real world today.
Okay, that is unfortunate, but, but good to know.
Well, you haven't seen season 2 yet.
You'll have to keep making friends with humans. I'm really sorry.
Okay. Yeah. And so, Claire, what you do is you work on technology for robotic arms inside factories.
Yeah, so what Veo does is we enable flexible and efficient manufacturing by making machines responsive to humans. So our first product gives industrial robot arms eyes and brains so that they can interact safely and effectively with people, with production workers in a manufacturing context.
And so how do you take into account the fact that these are very large robots interacting with humans? Like what type of safety precautions do you take into account?
Yeah, so one of the main reasons you want to use robots in manufacturing is for their superhuman capabilities. You want a machine that can pick up a 200-pound object. It can move it at 2 meters per second and set it down with sub-millimeter precision. And the physics of the mechanical capabilities behind that means that you have a very dangerous robot. And typically in factories today, these robots are kept in cages, and we always make it clear that it's not to keep the robots in, it's to keep people from getting close to the robots and getting hurt. So what we're building is a sensing and computer vision system that is designed to meet the requirements of a functional safety system, the regulatory requirements that are required for any industrial automation system that's protecting people from dangerous machinery. And that means everything from designing custom sensors and custom computers with dual redundant hardware to designing all of our algorithms from the bottom up so that they have well-defined failure modes that we can detect and respond to. So it's basically underlies everything we do.
And what are the types of tasks that robots should do on their own in factories versus the tasks that they should be working kind of side by side with humans?
So today, because you have to have basically robots in cages, a manufacturing engineer who's designing a process step has to decide, is this going to be a fully automated step or is this going to be a fully manual step? And if it's going to be fully automated, that means that there's a lot of extraneous automation to essentially get parts in and out of those cages, do a lot of sort of auxiliary tasks. If it's going to be fully manual, that means that it's typically going to be something that's hard for a person to do, that may have ergonomic challenges, require lift assist devices, a lot of challenges and often performance problems. So an example of something we'd like a human and a robot to be able to work together on is, for example, a robot can lift an electric motor weighing hundreds of pounds and position it precisely so that a person can come and attach fasteners, attach a wiring harness, do tasks requiring dexterity and judgment and flexibility.
Nice. And Mike, so what you're doing is definitely in the same realm, but a little different. So you're working on robots inside the home, geared toward people who need assistance.
Yes. Yeah, and ironically, we have similar issues because what we're trying to do is take off-the-shelf components. So instead of having to do our own depth cameras and all the sensors to get them at that factory-grade level, we're taking the range of new sensors that are coming out from AR headsets, depth cameras, gyros, all these things that pretty much any part in our robot you can get between stripping it out of something from Bed Bath Beyond or Best Buy. And that gives us, because those things are made in the billions of units, and so we can close together sort of a proximity of what Claire is doing, but in a not as functional level, but also with lighter capabilities. But we're working with robots that help carry things or deliver things for people who have some impairment of mobility themselves. But you have all the same requirements around safety that Claire is talking about, just at a different scale. And so one of the common themes that we come up against is people's expectations of what Rosie the robot or C-3PO in their house is going to be are just way, way too high compared to the reality of what we're trying to engineer and make functional and work with someone.
Yeah, and I know that you're not quite ready to show
Sure.
what your robot looks like, but yeah, just like you mentioned, oftentimes when we think of robots in the homes, they're kind of they look like androids with like these like human
Right.
elements to them. And can you talk a little bit about how you decided on what your in-home robot will look like?
Yeah, I can show some
Just like
slides
some
of
of
what
the
we said and
thinking.
what it wasn't going to look like.
Okay.
So I think if I go to next,
Yeah,
that go
let's
up?
see.
So
So not like that.
And I don't really want to diss the Pepper, but if you look at that, there was a lot of hype around social robots. And again, there's some really strong examples. There's Intuition Robotics. There's a stealth company by Paolo Bajanian that's doing some really interesting things on things that meet human needs. But with Pepper, there was a whole range. We had sort of this batch of robots dressed up to look like people, be able to gesture and interact, but what you look at that is the arms really aren't functional. They can move, but they can't pick up anything. And what they get relegated to is, now they're sort of retail greeters. The robot waves, it tries to engage somebody with big eyes, and then it points at the screen to do that. And we've had this generation of robots with screens on wheels. And what we're trying to do is move beyond that to sort of what can we do that's functional. And so when we look at stuff, this goes back to early research with PR2 from Willow Garage. And Willow Garage was a great company. Most of us wouldn't be at this conference without Ross and everything that came out of there. But that example, this is like that robot right there with doing pancakes, that can't be done safely. And people go, why not? Oh, I can see it being, the motors, and I'm sure Clara could probably list 25 reasons that's wrong there. But I'll give you one that nobody thinks about is there's pancake batter on the back counter. The robot turns on the griddle and goes to pour the pancake batter. And if it's away and a 5-year-old comes over and wants to grab the pancake that's on the griddle, there's no physical way that massive robot can move that distance the way a mom or dad could, grab the child and protect them. So anything you do on a robot, you automate, you own. And we have to think about all those consequences. Yeah. So the robots become more practical as we look at this. Again, this was interesting research they did with seniors out of Georgia Tech, and this is just delivering a pill bottle. And it was funny because the seniors wanted that, they want that use case, but that massive robot trying to navigate around, just not even figuring out what its cost is just a lot of taking up space. And everyone, it wasn't even just PR2, it would be everybody that I watched any university do this research, there was always this weird grab, like this person with back problems is having to reach to grab the robot, and robot's not really sure when to let it go. So we're really trying to work at this more natural flow of how do you bring items within reach and things. But what you see out of all this is these large robots, from an interaction point of view, they're overpowering people. They're larger than them. And so our thing was, okay, let's take that all apart. How do we focus on the function, make something that's really smaller, where the person feels, where the robot is really subordinate to what the person is doing, and doing that. I'll just give you another example. And the reason I throw these out is that when I go and show people like our product and I go and pitch it to a senior living community, they go, oh, I saw Carobot 4, this video. It's like, well, this is great, we want that. And that's a concept of it. That's Carobot. I think it has like 33 degrees of freedom, or 31, something in that range, and is able to pick something off of a shelf. And that's not reality. I think Clara can tell you, like 31 degrees of freedom when you're making a robot is 31 things that go wrong exponentially when you're manufacturing. So, and now what it's done is if you look up, Carobot now, it's a retail greeter. They took the arms off, they don't have it bend. and it's in the store again. So ours is doing something different, but I'll just give you an example. I think someone that Toyota is going to be talking later today. You look at what they're doing with TRI, and they have a much more practical example. Robots lower, smaller mass, circular. And if you look at what it's bringing over to someone, it's bringing a basket. That means that grasper can go and grab the basket, hold that, and let somebody take it out. And all those things are really key. And these are those types of interactions that we're trying to figure out and do within that envelope. So.
Yeah, and I'm curious. I mean, how do you, because obviously there's an immense amount of work that goes into training the robot how to interact with the human, but like in terms of actually training the human, like how do you train the human to know exactly how to interact with the robot and really to trust that robot?
One of the things that I think is very important in design of an automated system that's going to be interacting with a human is that you make the automated system predictable and you basically expose its its internal model of what it understands and what it doesn't understand. And I think you were talking about the sort of anthropomorphic robots, and I agree that that's very deceptive because what you need when you're interacting with a system is to have an accurate model of what it knows and what it doesn't. And so that's something that when we have these systems that basically control an industrial robot arm, that there's a couple of pieces that we include with that. One is that we make the way in which the robot arm will react to you, will slow and stop as you approach it, needs to be very predictable. So as a human worker interacting with that robot, you know what it's going to do based on what you do. Because then humans are really good at figuring those things out and optimizing around them. The other thing we do is we provide a visualization, a screen, that actually shows the robot's internal state, key pieces of that state, in a way that's easy for a person to understand when you're looking at them. So I think being true to the function of the robot and accurately conveying what it knows, what it doesn't know, and how it's making its decisions is actually the best way to create a functional interaction.
Yeah, definitely. And I think we're dealing with people, especially that are untrained, is just work within their natural flow, the metaphors that they already have. Our robot is actually more furniture-like than it is robotic, and we keep on reinforcing that in the industrial design too, because you see something and okay, there's water on a surface, I can pick it up, and you don't even have to explain. You don't have to get into okay, wave your hand and tell me when it's okay to let go of the water from the robot side. Just present something in the right way. So a lot of it is trying to understand the user flow. Where's their mind and their behavior and their instinct already going? And then how do we adapt the robot behavior in the system to that?
Yeah, I think there was a Walmart. They had their little like aisle bot, and they found that if you like put a Walmart apron over it, that like people treated the robot a little bit better. Because I guess it had more human-like qualities. Like I'm not exactly sure what they were doing before with it, if they were like kicking it or something. But but it sounds like that, at least for like in the home and in the factory, like it doesn't necessarily need to look human in order for humans to feel okay interacting with it.
I think it raises the expectations so high when it's anthropomorphic. It's what people want. When we did the original Lego Mindstorms, we were struggling with what the people wanted to, like, what would be the robot on the front of the box. And we eventually we used a part out of a Lego submarine with pneumatics to make something that would grab a can. And that was to give this chunk of plastic this ability to sort of look anthropomorphic and people could relate to it. But at least in the Lego system, you could build that. And people knew and had an expectation of it. But when you make things look like people think they're going to work like people. And it's not, that does, and then it becomes sort of devolves from there.
And then for your in-home robot, Mike, are you envisioning it being like voice command, or would the person kind of try to control the robot with a smartphone or smart device, or what would be the primary means of communication?
Generally, you command it. So one thing is you could take remote control, but we don't want people to do that because that puts a burden of usage on it. It's at most somebody might point to something or say, I want it to go here. A lot of it's voice. So it's one of the reasons we're funded by the Alexa Fund, not just because we like Alexa, but that's compared to 10 years ago. Now we have this capability to give complex directions of go here, get that, and come back. And so The voice is one, just simple buttons for some people who may have hearing problems or just prefer that I'm waking up in the morning, I just want the robot here, and I don't want to get into a discussion about it. So I think the idea is, again, follow the flow, but there's just buttons. I would say voice is first, just radio buttons, and then an app if you really need it. But you don't put the burden of them. One thing we realized was the amount of calculations the robot's doing to move itself in a space is actually pretty amazing. So we can't keep, even when we try to do it, we can't joystick the robot as well as it drives itself now. So we try to sort of smooth that out and put abstract ways that people can command it.
Yeah, and this, this is definitely geared toward the both of you, but I guess, start with you, Clara. What exactly are you training the robot to see inside the factory?
So we aren't training anybody to do anything. That's actually one of the, because of the safety constraints that we have, you need to use, as I said, algorithms with deterministic failure modes, and machine learning does not qualify. So our system is all built on deterministic 3D modeling. So we're analyzing a 3D space, figuring out what our sensors can see, what they can't see. We know, because it's an industrial work cell, we know what's supposed to be in there. So when you're designing a work cell and you're building the machinery and you're putting all the different pieces together, the robots and the conveyors and the fixed automation, you actually configure our system to know those things. So anything that is of sufficient size and shape that it could be a person, we're going to treat as if it is a person. And the design of the application and what that system does and like what inputs and outputs it actually comes from is built by a systems integrator. Really thinking of, they will call the robot arms that you see in YouTube videos of car factories. We call those robots, but really the robotic system in a manufacturing application is an entire work cell. So our sensors, for example, don't go on the robot for the same reason you don't have your eyes on your hands. The sensors are monitoring the space. And the training is essentially done during the development of that work cell. And then what we're providing is an intelligence, basically a spatial awareness, knowing what's going on in that space and where it is and is not safe for the robot to go.
Got it. Yeah, and then Mike, how does that work for you in terms of what your robot can sense
We'd love to have
it?
Clara's sensors, but we can't afford them. And the other thing we can't do is we can't put them in sort of God mode around the environment. That we're stuck with the robot, for the most part, needing the sensors on board, and that creates this visual perception images. Like, things we really care about that would advance robotics is how wide the field of view on something like Intel RealSense becomes. The wider that is, man, we are like we have less, blind spots and less of all these edge cases that we're trying to do. So we sort of move this space around us like a force field, and then people are coming in and out of that, and we're interacting with pets and babies on the floor, all sorts of wonderful scenarios that scare me at night, thinking about that could fail. But the important part is that 10 years ago we didn't have these sensors. Now we do, and they're rapidly coming down in price, and they're getting better and better in resolution. So we basically have this virtual radar field around us that really is going to enable a new generation of products, whether it's from us or someone else. There will be robots in the home in a much bigger way now.
And go on.
I was just going to echo, advances in sensing have been huge, and so we do build our own sensors, but we actually use the chipset. We're not quite crazy enough to build our own silicon. So the chipsets are off-the-shelf chipsets that we then build into a camera with redundant hardware and FPGA processing and other pieces. But the fundamental availability of that kind of technology is just huge for what we can do with robots today.
Yeah, and one thing we're talking about, like sort of stacking these things. So like software and processing power is going on that, the curve, and then sensors are close behind it. But Clara, you were talking about motors, and it was like, she understands, what I was talking about. But if you can repeat what we were talking about with the way motors aren't quite at that same.
Yeah, if you graph, the motor power per dollar availability over the past 100 years. Those exponentials don't work for you as well in hardware.
No, we're still dealing with rotational motors. They could be servos, they could be actuators, but the cost of those, the performance, they're getting better. Their quality is better, they're lower cost, but it's nothing like the processor that runs our robot is ridiculously affordable now compared to what it would have been 10 years ago.
Yeah, and then even just kind of looking forward, 10 years from now, like, where do you see this industry really going? Especially, I guess we could just start first, Mike, with like in-home. Like, right now, I mean, it's not going to look like a human, but maybe 10 years down the line, it could, or even if it could, should it?
If it looks like a human, it won't be functioning like a human. In my lifetime, I'm not going to see something like C-3PO walking around the house. I had one of our investors who was like, I realized I want this guy to invest. He said, if you start as a VC in robotics and you've worked, if you have a perspective after working 1 year or 3 years in the space, you get one perception. If you've been in it for 20 years, you have a whole different sense of the timeline. And it just isn't moving that fast. And we aren't changing fundamentally some things. Like we do have the walking robots, we do have the back-flipping robots and things like that, but we still aren't moving those legs any differently. We don't have, the other sci-fi thing is Westworld. We need Westworld. We need 3D printed muscle fiber and skin and the whole thing to go to that. And maybe there'll be something in the middle, or it'll be mannequin-like or trying to represent human, but it won't be functionally what we do. I don't know what you think there.
Yeah, no, I mean, I think that idea or promise of sort of general AI, robotic systems that can really understand the things that we as humans understand. And you were talking about, manipulation. These things, they're incredible. Like
Yes.
the things that a human can do, with their hands, with their eyes, with their understanding of the physical world is really tremendous. And so, we think about manufacturing. That's not something that actually I think a lot of people think about frequently, but manufacturing underlies the modern world as we know it today. We think about the planes, trains, and automobiles we took to get here today, the appliances that care for our clothes and prepared our food, the generators that power our cities, the construction equipment that builds our cities, all of those things are made in factories. And when people think about the future of a factory, some people's ideas are you have that kind of the lights out factory and all this equipment humming 24 hours a day and not a human in sight. But whenever anybody's tried to build a lights out factory for durable goods manufacturing, it fails. And we really believe that ultimately that's a technology dead end, that in a world with the pace of product innovation that we have today, there's no way you amortize the full cost of automation over the life cycle of the product. That product's obsolete by the time you're done. And so what we really need is a manufacturing concept that is fluid and dynamic and changes quickly. And what that means is you want humans with their intelligence and their flexibility and their understanding. So that's why we started Veo Robotics, because we really believe that the future of manufacturing is going to be humans doing what humans are good at and robots doing what robots are good at and working closely together. And that, if anything, I feel like the idea of general AI almost holds robotics back. Because instead of thinking about how should robots work and what could robots do with what they're good at that will help people, whether it's in their homes or in a factory, we're trying to get robots to do what humans do. And so really we need to be thinking about letting robots, let the robots do robots. And that there's a huge amount of value to be unlocked in that with the new kinds of technologies that are available today.
Yeah, and I think we're looking at the same way, is that we're really clear when we start talking to a home care agency or independent living, we're not out to replace caregivers with robots. What we are trying to do is, one, give autonomy back to people that have some need for care or some impairment, so they have more self-control over the world, even when there's a caregiver present. But the other part is to extend the impact of a caregiver. So are there things that a caregiver can set up that now they're gone for the day, but the robot can now automate and deliver or take up or allow for remote connection or some monitoring aspect and all that. So it's this interplay. It's robot as assistant is in that mix. And it's heavy, small assistant, big person in that equation for us. But that's the way we balance it. And then, so I think you'll see these co-robots sort of flowing out in different ways as we figure out those economies and the benefits that we get out of it.
The thing is, you're saying it's when automation comes into any system, you almost never have a situation where the automation does exactly what a human used to do.
Yeah.
The automation will always there's parts of that task, usually the less value-added parts of that task that can be automated, and then you leave a person able to do the higher level functioning. It's never build a machine to do exactly what the human did before.
Yeah.
Nice. Well, you've given us a lot to think about. So yeah, this has been awesome. Thank you so much.
Thank you.
Yeah, thanks. Thank you.